Okay, we're given a graph of a solution set, and we want to rewrite this in interval notation, inequality notation, and set builder notation. So as we look through this, it looks like we have one interval going in between 1 and 3. So these are going to be the endpoints for our interval, 1 and 3. The next determination we need to make is, should we include 1 and should we include 3? All right, in this case, because we have a filled-in circle at 1, see, it's a filled-in circle here. What we want to do is include that in our interval. To do so, we're going to use square brackets to say that point, that one value at 1 is included. Now, the same thing is going on here at 3. It's a filled-in circle here. That corresponds with including it, as does the square bracket. All right, we also have another interval going from 5 and then off to the right-hand side. From 5 off to the right-hand side here. So what we're going to do is our left endpoint there is going to be 5, but it doesn't end over on the right-hand side. We have an arrow saying that continues on forever. So we think of infinity, this mathematical concept, as being way out there, bigger than all the rest of these numbers. It just continues on forever. Now at 5, we have an open circle. Now that open circle means that 5 is not included, but these values very, very close to 5 would be included. They're in the shaded region, like 5.001. So to say that 5 is not included, we're going to use a parenthesis right here to indicate that. Now what about infinity off to the right-hand side? We can never get to infinity, so we say infinity is not included either. So again, it's going to get a parenthesis on this side. Infinity and negative infinity are never included, so they're always going to get parentheses for interval notation. All right, now as far as we have two separate intervals here, to indicate that both of these are part of our solution set, we're going to use a union symbol in between. That means that both 1 to 3 and 5 to infinity are both part of our interval notation, both solution sets. All right, next let's do inequality notation. Now our inequality notation, we're thinking of these as being x values. Well, x fits in between 1 and 3 for that first interval. And we would say that 1 is less than or equal to x. We're using the or equal to because it was a filled-in circle and included, or a square bracket with the interval notation. And something very similar there as we're looking at 3, again, filled-in circle, so it's going to be less than or equal to 3. And x fits in between those two. And then over on the right-hand side, we can also say that, well, our x values are bigger than 5, so we can say, comparing those, 5's our left endpoint, x is going to be bigger than that, but we're going to use less than with a strict inequality this time around. All right, it's a strict inequality because we had an open circle here saying that 5 was not included, but any x value would still make a true statement here if it was just a little bit bigger than 5. All right, now we do not include less than infinity. All right, because that's pretty redundant, everything's less than infinity, so we're not going to include that. Finally, set builder notation, we're going to do squiggly brackets, the set of x, vertical line where we say such that, and then we copy and paste our inequality notation. So 1 is less than or equal to x is less than or equal to 3, or 5 is less than x. And then we close this off with squiggly brackets at the end. Very mathematical terminology, squiggly brackets. All right, hope this helps out as you're working on converting back and forth in between graphs, interval notation, inequality notation, and set builder notation. Good luck.